Namaste everyone. Today we are going to discuss one of the very important topic from real numbers, how to prove a number is irrational. We know that irrational numbers are non-terminating, non-repeating decimal numbers. Root 2, root 3, root 5, all these are irrational numbers. But here we do it by contradiction method. We will say, let us assume that root 2 is a rational and we can write it in p by q form. We all know that number which I can write in p by q form where q is not equal to 0 is nothing but rational. So here also we have assumed that p and q are co-prime. This is very important keyword. This co-prime is very important keyword. There are few keywords for which we teachers look for. The co-prime numbers are numbers which have no common factor other than 1. This is important, other than 1. Whatever I am writing with red is for our understanding basically. So I will do transposition. If I send q on this side, this we have to write. I will do squaring both the sides. Squaring with the squaring, root of 2 will go off. Now by fundamental theorem, I know that if I am multiplying something to 2 to get p square, that something is q square here, then 2 is factor of p square. Also tell me one thing, how we get the p square? P square is a perfect square, right? What is perfect square? You get it as p into p. Definitely 2 should be present as a factor, right? It should be present as a factor in p. Then only it will come as a factor in p square also. So yes, 2 is factor because, so yes, 2 is factor of p also. Now, if I substitute this, p is, I can write as 2 into c, something I am multiplying. Therefore, p is equal to 2 into c. If I substitute here, not here, I will substitute in this second equation. So, it will become 2q square is equal to 2c square. So, what is it? 4c square is equal to 2q square. So 2c square is equal to q square. With the same logic, 2 is vector of q square and 2 is vector of q also. But it is contradiction. Contradiction to what? We assume p and q are, but p and q are co-prime. And here we have they have here 2 is coming as common factor, na? Right? 2 is coming as a common factor. So it's a contradiction, right? Co-factor was what? It won't have any common factor, but 2 has come as a common factor. Contradiction arises because, again and again, red pen. Contradiction arised because we assumed root 2 as rational. Therefore, root 2 is irrational. As I am telling you, in some or other form, this question almost come every year in exams. So please revise it properly, do it properly, and attempt an exam.